in this video we will see how to interface a ultrasonic sensor HC-SR04 to Arduino R4 Wi-Fi board. Okay, so we are already talking about various sensors, right? In this particular video, we will talk about this HC-SR04 sensor, which helps to measure the temperature of the target. Like for example, let us assume you have a target somewhere here. Okay, you want to measure the distance from this particular Arduino R4 board to that sensor. You can use this ultrasonic sensor. So to do this, you should have this sensor as shown here, okay, which actually has an option of transmitting the ultrasonic waves on one side and receiving the ultrasonic waves on the other side. And then there is a discrete circuitry behind this which actually helps to transmit and receive, and the resultant output is provided on the echo side. Okay, so there are 4 pins on this particular sensor. One is power, which has to be given 5 volts. This only operates on 5 volts, and then definitely a ground pin, and the D8 is connected to the echo pin of this sensor, and the D9 is connected to the trigger pin. So there are 2 pins, trigger pin and echo pin. So trigger pin is used to trigger the sensor. Echo pin is used to receive the response from the sensor. So let us look at how this trigger and echo works here. Okay, here is the waveform from the ultrasonic sensor data sheet. So as you see here, first we need to give power supply to the ultrasonic sensor, the 5 volts and the ground, and then on one of the pin, that means the trigger pin, we have to give a 10 microsecond pulse which actually initiates the sensor to generate 840 kilohertz pulses to be transmitted from the ultrasonic transmitter. Okay, as we have said, there is a transmitter and receiver, right? So once the trigger signal is given, internally the sensor generates these pulses, and these are transmitted from the ultrasonic sensor. And once these are transmitted and it hits a object at a particular distance, the waves reflect back, and the receiver starts receiving the pulses again. Okay, now on the echo pin that is present on this particular sensor, we just receive another high pulse because all the processing happens on that particular board, and we only receive either high or low. Okay, so once we on the echo pin, right, we start receiving the high signal, and the time for which this high signal stays is used to calculate the distance. Okay, this is how the HC-SR sensor works. Okay, and that time period for which the signal stays high should be read by our Arduino R4 Wi-Fi, and the distance can be calculated using the formula time in microseconds into 0.034 divided by 2. What is this 0.034 is nothing but the speed of the sound. Okay, so in centimeters we are talking here. So this is how we actually use the sensor to calculate and see how much distance the target is at. Okay, a very simple hobby project which can be executed in a fraction of, in a few minutes, we can say. Okay, now let us look at the code. So this is the Arduino code which is written in Arduino IDE. As you see here, These are the pin configurations that are there, which we have already talked. And so in the code, what we have done is we actually declared two variables, trick pin and echo pin, and assigned the pin numbers. Okay, and then there are variables. So we are actually trying to print out the distance on the command prompt. So for this, we are actually using serial begin to print on the command terminal. And these are two pins, right, which we talked. One is trigger, basically, which is the input. Echo is the output from the sensor. So they are declared in similar way, and then there is a serial print. And here you can see here, first we are triggering. So initially, before sending any triggering, we are just trying to have the signal low, okay, for some time, 2 microseconds. And then what we are doing is we are trying to make it high for 10 microseconds and then make it low. That means this is the trigger pin which actually sends out the transmit pulses, which we have talked, the 8 pulses of 40 kHz on the output of ultrasonic sensor. And we are trying to read the pins here, okay, to see how much duration this high is. So the actual functionality is written in the background. So we have used the inbuilt function, and then we are trying to convert into a distance, okay, and then we are printing. So this is how the simple code is written. So this helps calculate the distance using the ultrasonic sensor. The code, yeah, this code you can get anywhere from the websites, or you can use ChatGPT to generate anything. Only thing is you need to know what to connect, how to connect, and how to use the sensor. These are the major things. Okay, the code, you have many open source websites available. You can get lot of codes from anywhere and just try it out, and write a small application based on this code as well. Thank you. So we can see the data getting printed here. Okay, the distance right now, the object is at a very long distance. So right now I'm trying to obstruct it. You can see the distance, and I'm moving the object away, away. Okay, you can see it's just increasing the distance. So this is how you check by placing an obstacle, and the project helps you to calculate the distance of the obstacle. Okay, very useful, right? A simple demonstration, a very simple code for beginners, and especially for the guys at school level, just to see and understand the sensors, the distance measurement, and all. This is a very good exercise.